So in this video, we are going to see Autonics ADIO EC series IO-Link EtherCAT communication. The PLC we are going to use over here is Codesys Soft PLC. The setup is as follows. So this is our ADIO EtherCAT IO-Link master, of which the top port where the green color wire is connected, we can see, is our field bus port. That is our EtherCAT port which is going to communicate with our soft PLC. Hence, I have connected this port with the Ethernet cable to my PC. Then this cable we see, the gray color one, is the power cable which is supplying power to the IO-Link master card. It is going to supply the sensor and the actuator power supply. Then we have over here PDCT cable. This cable is used for communicating Autonics ADIO IO-Link masters with the PC on at IO-Link software. So for maintenance purpose, you want to check the port configurations, we can use this PDCT cable for checking the same. Then we are having the 8 different ports. So these ports we can configure like a standard input output or as IO-Link ports. We are using port 0 to configure Autonics PRFD series IO-Link inductive sensor. So let us see how this communication can be configured on Codesys Soft PLC. So let us look at IO-Link communication with the ADIO IO-Link masters. So I have connected the PDCT cable to my PC. It will create an COM port connection with the IO-Link master. So click to add the master. The COM port will be available. Please select the COM port which is connected to that PDCT cable. Once we do the connection, it will automatically check the IO-Link master and load the master configuration. Once the master configuration is loaded, we can see the vendor name, vendor ID, the master name, EtherCAT ID, software revision, hardware revision of the IO-Link master. We can do the port configurations. So in my case, the port 1, I'm going to use it for IO-Link communication. So I can say IO-Link auto start. Here I can link my IODD file of the IO-Link sensor. In my case, it is already loaded. In your case, if it is not loaded, you can import the IODD file. You can download and give the location of your downloaded IODD file here so that it will be imported here. You can select the device variant if there are multiple variants into that same IODD file. In my case, this variant is the same one. Once we select the variant, we can do the selection and we can say apply for this port 0. Okay, so once it is done, we can see the port is connected and it is ready to exchange the data with my IO-Link sensor. Okay, we can also see the data is coming over here. If I change, if I bring any metal object in front of my sensor, we can see the data is changing. Okay. Yes, rest all of my ports are inactive. So since I'm not using it, I have kept other all ports as inactive. Specifically, if you need to go and check the data for port 0, we can also select port 0. Okay, and check all the port 0 parameters, the identification parameters, observation parameters, okay, and diagnostic informations of the sensor. We can read all this configuration data of sensor. As well as the diagnostic information. Process data will also be available in this process data tab. Events, if any, will be available. Data storage function, if using, the data will be stored into the respective port. So once this is configured, um, our port 0 has been verified for successful functioning of IO-Link sensor as well as the reception of IO-Link data. Now let us communicate this ADIO IO-Link master with EtherCAT to Codesys soft PLC. Let us start um, the configuration for communicating ADIO IO-Link master, the EtherCAT field bus communication with Codesys PLC software, the Codesys soft PLC. So we can see in the video over here, okay, only two LEDs are right now on. These two LEDs are nothing but sensor supply, actuator supply. Then we have the run LED, which will turn on once the master communication, field bus master communication gets set up. So when the soft PLC will start to communicate with the IO-Link master, the run LED will turn on. Then there is error, and then we have the 100 Mbps, 100 Mbps baud rate, as well as uh, the network traffic LED. Okay, so there are two network traffic LEDs since there are two network ports available on the device. So we can see once I have not yet connected the EtherCAT cable to my PC. Once I connect the EtherCAT cable to my PC, okay, so the 100 Mbps LED as well as the traffic LED has turned on. Now in my PC, let us start with the configuration in Codesys. Let me create a new project. Let's give a title to the project. We'll create a standard project. I'm using the soft PLC, hence I'm using the device control win. Once the project tree is created, we will start to add devices. So we are going to add first the EtherCAT master. Okay, and on this EtherCAT master, we will add our field bus module ADIO EC. Okay, by default, this will not be available in your Codesys software. If you want to add this, we need to download ESI file from Autonics website, and we need to install this ESI file. What is the process to install this? Is we can go to Tools, Device Repository, click on Install, and then browse to the respective folder where you have kept your ESI files. Okay, I have already installed this, so that's why I'm able to see those files. Let me add those files into the project tree now. So this is my ADIO EtherCAT module, which I have added below my EtherCAT master. Okay, so once this is done, we need to configure the data packets that are necessary for each of those ports. In my case, port 0 has been configured for IO-Link communication with my inductive proximity sensor, which is IO-Link based. So for that purpose, if I check my data packet of my inductive proximity sensor, we can see the process data is of 2 bytes, byte 0 and byte 1. In byte 0, I'm getting few indications with respect to warning, instability detection, and sensor output. And in byte 1, I'm getting the detection level. Okay, so 2 bytes are enough for my input data packet. So let us configure the port 0, this channel 0, port 0 for 2 byte process data input. IO link 2 byte process data input. Okay, so based on sensor that you are going to connect, you need to check this size and add the same. So once this is added, okay, next step is to turn on the soft PLC. So in my system tray here, I need to start my soft PLC. Once it turned to green, it is ready. I can connect to my soft PLC. Scan my PLC. Okay, so once I'm connected, I can, which is the Ethernet card that I'm going to use to do the EtherCAT communication. So you can select here. Okay, you need to download my, enter my username password to proceed. So okay, so out of this adapters, my current adapter that is connected to EtherCAT IO-Link master is Ethernet 2. Okay, so once this is connected, let's download the configuration into the soft PLC. And let's start the soft PLC. So once the soft PLC is started, we can see the communication is successful, and uh, we can also see the run LED has also turned on, okay, onto my IO-Link master. Okay, now if I want to check the data coming in for this port 0, I need to enable one thing. So let me log out. Let's go to channel 0, module IO mapping, and let's enable this always update variables so that we can check the sensor value coming in port 0. Let me download it and again go online. Okay, and here we can see these are the, this is byte 0 and this is byte 1, and in byte 1 we are receiving the detection level. Okay, let me take an metal object and take it in front of IO-Link sensor. We can see the sensor value is changing. Okay, we can see that sensor value is changing with the inductive part.